Hi, good evening, everyone. This is Shefali Mam, and in this session, we are going to discuss one of the application from greedy technique, that is Huffman coding. So, Huffman coding is very important, and as well as a similar concept we are using in the concept based on binary tree construction. Apart from that, we can say that Huffman coding, जैसा कि नाम से समझ में आ रहा है, this is one of the encoding technique. यानी कि आप कोई characters send करते हो, you want to send some message which contains different set of characters, so this is going to generate the code for the same. Uh, so we can say that it is one of the encoding technique. It is one of the encoding technique. Now there are lot many encoding techniques available. Then why Huffman coding? Because Huffman coding is also going to reduce the code length. That means it is going to compress the data. So we can say that it is a data. It is one of the data compression technique. One of the data compression technique. That means it will produce minimum number of bits that can be transferred in order to send some message. Data compression technique. Now there are multiple methods to send a code. For example, we want to send a message which contains different set of characters. I'm taking the characters A, B, C, D, E and F. और हर कैरेक्टर की फ्रीक्वेंसी गिवन होगी. फॉर एग्जाम्पल इफ आई एम सेंडिंग अ मैसेज लाइक हेलो, so in this case there is a frequency of h. frequency means कितने times repeat हो रहे हैं. h is repeated for one time, e is repeated for one time. इस मैसेज में l कितनी बार आ रहा है, so that is coming for two times, 0 is coming for one time. So we can say that we are given with the different set of characters and their frequency. आपको क्वेश्चन में कैरेक्टर्स के साथ साथ फ्रीक्वेंसी या प्रोबेबिलिटी गिवन होगी. दैट मींस इफ 100 characters are coming up, out of that, what is the probability that will be getting the A? What is the probability that will be getting the B? So this way, corresponding to every letter or the character, you will be given with the frequency. Let us assume that the frequency for A is 50, frequency for B is 5, frequency for C is 4. कुछ भी frequencies consider कर रही हूँ मैं. Frequency for D is 10, frequency for E is 30, and frequency for F is 1. So if we check the total, so this comes out to be 59 and 40, 99 and 100. So in total, I'm sending a message that will be containing 6 different characters, that is A, B, C, D, E, F, and total messages, total characters जो send हो रहे हैं, that is 100 characters are being sent. Now, if we use the concept of ASCII code means एक character को represent करने के लिए, for example, the code is 65. So in order to represent 65, number of bits, okay, let me write here. With the concept of ASCII, let's say for each character, 7 bits are required. Character, 7 bits are required. अगर एक कैरेक्टर को सेंड करने के लिए 7 बिट्स चाहिए, तो 100 कैरेक्टर्स के लिए कितनी बिट्स चाहिए? ऑब्वियसली इट विल बी 700. सो टोटल बिट्स required to send 100 characters, that will be equal to 100 characters hai, and in order to send one character, 7 bits are required, so into 7, so which comes out to be 700 bits. This is with the standard approach when we are using the concept of ASCII. There is another method. Let me call this as method 1. Method 1. With the method 2, that is uniform encoding. Uniform encoding. So uniform encoding says that in order to send one character, same number of bits will be transmitted. Now we have 6 different characters. So in order to uniquely identify 6 different characters, how many bits will be required? So we have 6 different characters, that is A, B, C, D, E and F. In order to represent these 6 different characters, how many bits are required? So that is based on the combination of the bits. So if I'll be taking 2 bits, 4 combinations are required, but यहाँ पे हमारे पास 6 characters है, so 4 won't work here. If I'll be taking 3 bits, I'm so sorry. If we'll be taking 3 bits, with 3 bits, 8 combinations are possible. But how many combinations we want to use? I'm so sorry. In order to represent 6 different combinations, we'll be taking 3 bits because we have 6 combinations. With 3 bits, 8 combinations are possible. Minimum number of bits le rahe, maximum jitni marzi le lo. But since we want to reduce the code length, so that's why we are focusing on the minimum number of bits. So let's say in order to represent A, I'm using 000. To represent B, we are using 001, 011, 100, 101, 110. So I could have taken 2. Anyhow, any 6 combinations you can use, but let's take this in the sequence. Anyhow, that really doesn't matter. 2, 3, 4, 5. So apart from this, 2 more combinations are there. We are not going to use these remaining 2 combinations because with 3 bits, we know that 8 combinations are possible, but we just need 6 combinations. So these are not used. Now, in order to represent each character, 3 bits are taking place. To represent with this approach, to represent each character, to represent each character, this is taking 3 bits. So we had 100 characters. So that means using encoding, total number of bits required in order to send 100 characters, total bits required to send 100 characters, how many bits will be required? एक character के लिए 3 bits चाहिए, तो 100 characters के लिए obviously it will be 300 bits. So into 3, that comes out to be 300 bits. Can you observe one thing? With the S key, with the method 1, it was taking 700 bits. यहाँ पे 700 bits चाहिए थी, but now it is taking just 300 bits. So the number of bits are reduced. Same message send करने के लिए 400 bits reduce होगी. Now the question is, can we reduce it further? Yes, definitely it is possible with the help of the Huffman coding. So in the Huffman coding, it is saying that the number, the letters which are frequently used या फिर जिनकी frequency ज़्यादा है, उनके लिए less number of bits will be dedicated, and the letters which are rarely used, जिनकी frequency कम है, उसके लिए अगर ज़्यादा bits भी लग रही है, then also the total bits or the average bits comes out to be the less. So the Huffman coding is basically based on the concept of non-uniform coding. Non-uniform coding means सारे characters के लिए same number of bits are not required. It depends on the frequency of the character. If we take the frequency, let's take the letters that we have taken A, B, C, D, E, F. Frequency was 5, 4, and then we had taken 10, 30 and 1. So this is the frequency. If we see here, out of total 100 characters, A gets repeated for A kitne times are 50 times. That means this should contain less number of bits, and the least frequency is with the characters F and C. So every time what we are doing is we will be constructing the binary tree starting from the letters which are having the least frequency or the least probability. And since it's a coding technique, तो हमें code generate करना है. So what we'll do is we'll be keeping the smaller value or smaller left side and greater frequency on right side. At a time, obviously, it's a binary tree, so we can take maximum 2 nodes. So every time we'll be merging 2 nodes, left side and right side. So here the minimum frequency is, I need 2 nodes. Here the minimum frequency is 1. और better idea is जितनी भी आपको frequencies दी गई हैं इनको sort कर लीजिए. It will be easy for you. Moreover, the algorithm is basically using the concept of the heap tree, because we know that when we have the min heap, from the given set of elements, min heap tree will always be returning the minimum element, because we know that in the min heap tree, the root element is the smallest element. So every time when I'll be deleting the root, I'll be getting the smallest value. So let's maintain these elements in the min heap tree. Min heap tree. So arrange these elements in the ascending order. We are given with the character F with the frequency 1. Then next minimum is for C with the frequency 4. Next minimum is B with the frequency 5. Next minimum is D with the frequency 10. Next is uh, E with the frequency 30. And next minimum is E with the frequency A with the frequency 50. So what I have done is I have created a min heap tree. So every time now I'll be getting the minimum element. So delete the first minimum. So that means this is the smallest one. So it will be coming on the left hand side. So I'll be deleting the first minimum. That is, let me write here. This is representing the frequency 1 and it is for the character F. Take the next minimum, जो next minimum आएगा, obviously it is greater than what we have deleted now. So that is 4. 4 will be on the right hand side because it's greater. This is the frequency of C. Now merge it, because we are constructing a binary tree. Binary tree means 2 nodes will be merged into a single node. 2 nodes will be having the same parent. So take the sum. 4 plus 1 is 5. This comes out to be 5. So whatever value you are getting, push it into the min heap tree. Again, take the next two minimums. 5 is already there. Next is 5. So I'll merge this. This 5 is the frequency of the character B. Merge it. This comes out to be 10. So we deleted 2 elements. सबसे पहले हमने इन दोनों को merge किया. Then we are merging these two. Now whatever result is coming up, इसको भी हम sorted order में रखेंगे, because anyhow this is also a part of a tree now. So 10. Take the next two minimums. This is something which we have got now. Next is 10. If the value is greater or equal, keep that on the right hand side. This is the frequency of D. 10 plus 10 is 20. These two are merged. So here we are getting 20. Take the next two minimums, 20 and 30. 30 is greater, so we'll be keeping that on the right hand side. This is the frequency of E. Merge it up. Here we get 50. Next minimum is 50, so 50 will be kept here. This is the frequency of A. And total comes out to be 100. You can see here the total number of characters that we were given. The total frequency was given as 100. रूट पे आपके पास 100 आ गया. तो इस तरीके से अगर आपको frequency दी है या probability दी है, so total जो भी frequency या probability होगी, total will be available at the root. Now you can see that here we got the binary tree. Now we have to generate the code. Code कैसे generate करेंगे? Let's say to the left side we are giving the 0 and right side पे 1. तो या तो आप left side पे 0 दोगे, right side पे 1 दोगे, या left side पे 1 दोगे, right side पे 0 दोगे. Anyhow you can follow any approach. If they are asking for the code, it will be given in the question that what will be the code. Okay, but standard one is this one. To the left side we are taking the 0 and to the right side we are taking the 1. So let's assign the codes. This is 0 and 1. This is left child is getting the value 0, right child is getting the value 1. Left is getting the value 0, right is getting value 1, 0, 1, 0, 1. Now, if I want to write down the codes, we can see we have obtained the codes for A, B, C, D, E and F. अब चेक कीजिए अगर मुझे रूट से A पे जाना है, how many edges do we need to cover? We just need to cover one edge, that is 1. Similarly for E के लिए रूट से शुरू करके this is 0 and then 1, so 0 1 is the code for E. For D it is 0 0 1. रूट से शुरू करना है और आपको उस पर्टिकुलर लेटर पे पहुंचना है. यू कैन सी हियर ऑल द लेटर्स आर नथिंग बट दीज आर द लीफ नोड्स, सो आफ्टर दिस there won't be any edge. Next is 0001. This is for B, 0001, and for C it's 4 times 0, and then we are getting 1, and for F we are getting 5 zeros. 5 zeros. So we have generated the code. इसके basis पे question कैसे आ सकता है? You might be given with some sequence of bits and they'll say that what will be the decoded message. आपको encoded message given होगा and you have to identify the decoded message. For example, if you are given with 1 0 1 0 0 1 0 0 0 1 1 1. This is some message given to you. What will be its equivalent decoded message? तो आप यहाँ पे ऑब्जर्व कर सकते हैं, या तो आपके पास एंडिंग विद 1 हो रहे, जीरोस कितने भी आए इट एंड्स विद 1, और 5 consecutive zeros is representing some character. If I'm getting single 1, that means this is representing A. If I'm getting 0, 0 के बाद या तो 5 0 आए total, but here we are getting 1, so 1 is representing the termination here. Observe the codes that you have obtained. This is the code for E. 001. 001 is the code for D. 000. 000 से कुछ नहीं बनेगा. It should end with 1. 0001. This is the code for B. And then I'm getting single 1, single 1. So this is for A. So ultimate encoded message is decoded and it comes out to be A, E, D, B, A, A. This is one type of question that can be asked on the basis of the Huffman coding. Other one is आपसे total number of bits पूछी जा सकती है. Now you can see in order to represent A, 1 bit is required. For B, 4 bits are required. For C, 5 bits are required. हर character के लिए same number of bits नहीं चाहिए. अगर आपसे एग्जाम में number of bits के ऊपर question आ रहा है तो आपको इनफैक्ट codes भी generate करने की जरूरत नहीं है. रूट से चेक करो कोई भी लीफ नोड कितने डिस्टेंस पे. फॉर एग्जाम्पल A is at a distance of 1. So for sure, for A, 1 bit will be required. For E, this is at the next level, 2 bits will be required. For D, 3 bits will be required. So आपको codes लिखकर bits count करने की जरूरत नहीं है. Just check जिस particular character के लिए आप bits find कर रहे हो वो tree के कौन से level पे आ रहे हैं, and ultimately you'll get the number of bits. Moreover, you can see here for 1 bit is required. Here 4 bits are required. You can see for B, 4 bits are required. Here 5 bits are required, 3 bits, 2 bits, and 5 bits are required. Now we had got 700 bits with the S key. With uniform encoding, we got 300 bits. Let's see with Huffman coding how many bits we'll be getting. So frequency of A is 50, and in order to send single A, 1 bit is required. So it is 50 into 1. For B, frequency is 5. In order to represent B, 4 bits are required. C, frequency is 4. In order to represent C, 5 bits are required. For D, frequency is 10. Number of bits required are 3 bits. For E, frequency is 30. 2 bits required. For F, frequency is 1 and 5 bits are required. Now just take the sum. So 50 into 1 is 50. This is 20. 4 into 5 is 20. 10 into 3 is 30. 30 into 2 is 60 and 5. Just take the sum. So it comes out to be 70, 90 and 120, 180 and 185. That means with the Huffman coding, in order to send this message, 185 bits are required. Now you can see this is method 3, Huffman coding. So we can see here for the Huffman coding, we are getting the binary tree. Moreover, it is reducing the number of bits that we are sending. This is a non-uniform encoding technique. With method 1, 700 bits were sent. With method 2, 300 bits were sent. And with method 3, 185 bits are sent. Okay. सो अल्टीमेटली आपके पास जब भी क्वेश्चन आएगा एग्जाम में आपको तीनों मेथड्स फॉलो नहीं करने डायरेक्टली they'll be asking for the minimum number of bits or they might be asking for the code, so you have to construct the binary tree with the help of the min heap tree. Every time we'll be deleting the two minimums. Whatever result is coming up, insert it into the min heap tree back and repeat the steps. So how many steps will be repeated? Every time we are taking out two minimums and inserting back one minimum. हमने क्या किया, दो minimums को delete किया, एक को वापस डलवा दिया. That means effectively one element gets deleted at every step. So you can see here we were given with 6 characters. How many times this step was repeated? This is 1, this is 2, this is 3. Two elements are deleted, one is inserted back. 3, 4 and 5. Total 6 characters the. Why we are getting 5? Because in the first instance, in the first step, we deleted two elements, but after that at every step, we are deleting one element from the min heap tree. So this means that total, if n characters are given, these steps will be repeated for n minus 1 times. I'm discussing this point because on the basis of this, we will be talking about the time complexity of the Huffman coding. तो जो आपके पास different algorithms, different algorithm designing techniques और application के basis पे questions आते हैं, they'll give you two lists. List 1 might be containing the algorithm designing techniques and list 2 might be containing the list of applications. You have to map that which algorithm which application comes under which algorithm designing technique. Or other type of question can be in the list 1 they'll give you the application names and in the list 2 time complexities will be given to you और आपको map करवाना होगा कौन सी time complexity कौन सी application की. So you should be comfortable with this one. I hope that the basic idea of Huffman coding is clear. So in the introduction only, I told you that this is one of the application of the greedy technique based on binary tree construction. So we are constructing the binary tree. The only thing is, जो usually हम trees construct करते हैं, we always start from the root node. But here in Huffman coding, we'll start from the leaf level by taking two minimums. And it is one of the encoding techniques. So we have generated the codes on the basis of the code also. कोड के बेसिस पे भी क्वेश्चंस आ सकते हैं एंड डेटा कंप्रेशन टेक्निक. तो नंबर ऑफ बिट्स जो आप सेंड कर रहे थे 100 कैरेक्टर्स के लिए दैट इज आल्सो रिड्यूस्ड. ओके, हिंदी में क्वेश्चंस करिए. चलिए कोई बात नहीं बबलू, अगला क्वेश्चन हम हिंदी में करेंगे. एक और क्वेश्चन लेते, बट उससे पहले if you are really interested in doing the NET or JRF or PhD from the reputed institutes of India, तो क्या करना है उसके लिए? How are you preparing? Do you need some trick? Definitely. पूरा लेंथी प्रोसेस फॉलो करके तो बहुत टाइम लगेगा प्रिपरेशन के लिए. फर्स्ट अटेम्प्ट में हमें अपना पेपर निकालना है, नेट निकालना है, जेआरएफ निकालना है ताकि हम टीचिंग में जा पाए, पीएचडी कर पाए. तो किस तरीके से करेंगे? सम ट्रिक्स नीड्स टू बी शेयर्ड. कब शेयर करोगे? फॉर यू सम स्पेशल सरप्राइजेस कमिंग अप, दैट इज ऑन द 27th of April at 5 p.m. So if you want कि आपके साथ वो ट्रिक शेयर हो, mark your calendars for 27th of April for 5 p.m. Okay, so नाउ लेट्स टेक वन मोर क्वेश्चन, एक और क्वेश्चन करते हैं। फाइल के अंदर आपके पास कुछ कैरेक्टर्स दिए हुए हैं, हफमैन कोडिंग का कॉन्सेप्ट यूज करना है। अगर हम हफमैन कोडिंग यूज करते हैं तो एवरेज कोड लेंथ क्या होगी। यहाँ पे जो पिछला क्वेश्चन हमने किए वहां पे हमने टोटल कोड लेंथ फाइंड की है, दैट इज 185। एवरेज क्या होगी, 185 बिट्स सेंड हो रही है 100 कैरेक्टर्स के लिए। टोटल 100 कैरेक्टर्स हमने सेंड किए थे, यानी कि 100 कैरेक्टर्स के लिए 185 बिट्स जा रही हैं। तो एक कैरेक्टर के लिए कितनी बिट्स जाएंगी, एवरेज विल बी 1.85। टोटल नंबर ऑफ बिट्स डिवाइडेड बाय द टोटल फ्रीक्वेंसी, दैट विल गिव यू द एवरेज। तो अब अगले क्वेश्चन में मैं पूछ रही हूँ कि एवरेज कोड लेंथ कितनी होगी। तो इसके लिए क्या करना है, आप टोटल बिट्स फाइंड करोगे, इतने सारे कैरेक्टर्स को सेंड करने के लिए टोटल कितनी बिट्स चाहिए, और उसके बाद वट एवर इज द टोटल गिवन टू यू, जो भी आपको यहाँ पे टोटल फ्रीक्वेंसी दी गई है उससे डिवाइड कर देंगे। तो फटाफट से ये सॉल्व करते हैं टू गेट द टोटल नंबर ऑफ बिट्स। सबसे पहला स्टेप क्या करना है, अरेंज ऑल दीज कैरेक्टर्स इन द असेंडिंग ऑर्डर। यहाँ पे हमें फ्रीक्वेंसी दी गई है A, E, I, O, U, S और T के लिए। तो सबसे पहले हम इसे अरेंज करेंगे असेंडिंग ऑर्डर में, ताकि हमें इजी रहे हर बार दो मिनिमम एलिमेंट्स को डिलीट करने। सो मिनिमम फ्रीक्वेंसी इज फॉर टी। टी के लिए मिनिमम फ्रीक्वेंसी आ रही है, दैट इज 1। फिर उसके बाद नेक्स्ट मिनिमम आई ओ के लिए, O 3, then U 4, then next minimum is 3, 4 is over, next minimum is 10, 12, 13 and 15, 10, 12, 13 एंड 15। जितनी भी फ्रीक्वेंसीज हमें दी गई थी हमने सबको सॉर्ट कर लिया। 10 इज फॉर ए, 12 इज फॉर आई, एस एंड ई। इतना क्लियर हुआ। पहले स्टेप में हम क्या कर रहे हैं, दिस इज स्टेप वन। इन द स्टेप वन वी आर सॉर्टिंग ऑल द फ्रीक्वेंसीज इन द असेंडिंग ऑर्डर, बिकॉज हमें यहाँ पे मिन हीप ट्री बनाना है। अब हम ट्री कंस्ट्रक्ट करना शुरू करेंगे फ्रॉम द लीफ नोड। सो लीफ नोड हियर इज, फर्स्ट टू मिनिमम्स को ले लीजिए, दैट इज T एंड O। सो लेट्स टेक हियर T। जो भी छोटी वैल्यू है उसको लेफ्ट साइड पे रखना है। आप मिक्स मैच नहीं कर सकते, बिकॉज अल्टीमेटली हमें कोड जनरेट करना है। अगर आप प्रॉपर मेथड फॉलो नहीं करोगे, कोड तो जनरेट फिर भी हो जाएगा, बट यू वॉन्ट बी एबल टू decode your message. This is 3 and this is for O. पहले दो मिनिमम्स डिलीट किए, इनको मर्ज करवाया, हमारे पास रिजल्ट में आया 4। 1 plus 3 is 4. Now take the next two minimums, 4 and 4। next 4 आ रहा है, 4 is greater than equal to 4, तो इसको हम राइट साइड पे रखेंगे। 4, this is the frequency of U। समझ में आ रहा है ये। अब इन दोनों को मर्ज करवा दो। मर्ज करवाने के बाद मेरे पास आया 8। These two elements are deleted। अब जो भी रिजल्ट आया उसको वापस हमने मिन हीप में रखा, ताकि हम नेक्स्ट टू मिनिमम्स ले पाए। अब नेक्स्ट टू मिनिमम्स में आ रहा है 8 एंड 10। 8 ऑलरेडी यहाँ पे है, 10 एक नई नोड क्रिएट करवा देंगे, 10 विद द फ्रीक्वेंसी 10 फॉर द कैरेक्टर ए। अब इनको मर्ज करवाया, 10 प्लस 8 इज 18। एलिमेंट्स हमने असेंडिंग ऑर्डर में रखे। नाउ 18 विल बी गोइंग एट द एंड। Take the next two minimums. Next two minimums are 12 and 13. So I'll be taking 12 and 13. 12 smaller here, so we'll keep this on the left hand side. This is I. And then next minimum is 13. इन दोनों nodes को हम merge करवाएंगे. This is for S. 12 plus 13 is 25. So result is 25. Whatever is the resultant node that will be inserted back in the min heap tree will get 25 here. Take the next two minimums, 15 and 18. 18 वाली already known है. 15 is the frequency of E. This is smaller than 18, so we'll keep this node on the left of 18. तो हम इसे left side पे रखेंगे. This is 15 and this is the frequency of E. Merge them. 15 plus 18 is 33. So here we are getting 33. Take the next two minimums. So ultimately total comes out to be 25 plus 33 is 58. So total frequencies that were given, that was 58. So we got 58 at the root node. अब हमें find करना है कि कितने characters चाहिए. Let me write here A E I O U S T. Frequency of A was given as 10. क्योंकि मुझे total bits count करनी है, so I'm taking all the frequencies 3, 4, 13 and 1. अब क्या हमें एक्चुअली कोड जनरेट करने की जरूरत है? कोड पूरा का पूरा जनरेट करने की जरूरत नहीं है. सीधा सा तरीका है कि आप बिट्स चेक कर लो, क्योंकि अल्टीमेटली यहाँ पे आपसे कोडिंग या डिकोडेड मैसेजेस के बारे में बात नहीं कर रहे हैं, एवरेज कोड लेंथ की बात कर रहे हैं. कोड लेंथ मींस हमें सिर्फ और सिर्फ बिट्स पता होनी चाहिए. तो हम कोड्स फाइंड करने में टाइम वेस्ट नहीं करेंगे. लेट्स सी कि रूट से कितने डिस्टेंस पे आ रहा है, 1 बिट, बट यहाँ पे कोई भी कैरेक्टर नहीं आ रहा. देन 2 bits are required at the next level. कौन कौन से letters आ रहे हैं यहाँ पे? I, E and S. So 2 bits are required for I, E and S. 2 bits. For A, 3 bits are required. A के लिए 3 bits चाहिए. 3. U, 4 bits. U के लिए 4 bits चाहिए into 4. T and O के लिए 5 bits are required. T and O requires 5 bits. तो इससे आपके पास टोटल नंबर ऑफ बिट्स कितनी सेंड हुई वो आ जाएंगी. 10 into 3 is 30, 15 into 2 is 30, 24, 15, 16, 26 and 5. So this comes out to be 24 plus 26 is 50, 50 and 60, 110, 125, 141, 146. So total bits are 146. 58 letters को send करने के लिए 146 bits send हुई, but here they are asking for the average code length. So average is nothing but average code length is obtained by dividing the total number of bits. Total bits को हम divide करेंगे with the frequency or the total frequency that is given to you. Substitute कर दो. So here it is 146 divided by frequency was 58. So this will give you how many bits are sent per character. Make sense? So again we have constructed a mini tree. एक और question कहते हैं and then we'll discuss the time complexity. A file contains A, B, C, D, E, F. 6 letters, 6 characters are given to you. A, B, C, D, E, F with the respected frequencies of 45, 13, 12, 16, 9 and 15. And we are supposed to return the average code length. So first step is to arrange all the frequencies in the ascending order. Every time delete 2. हर बार हम minimum 2 को delete करेंगे because यहाँ पे हम mini tree बना रहे हैं for the Huffman coding. So just try it and find out what will be the average code length. Step 1 mini बनाना है तो arrange करवा लीजिए इन्हें. 6, 12, 13 E, 6, 12 for C. For B we are getting 13. Then for F, we are getting 15. For D, we are getting 16. And for A, we are getting 45. Now, this is step 1. We are going to create the min-heap tree. Now start taking first two minimums. दो minimum से शुरू करेंगे, leaf level से शुरू करेंगे, go to the leaf level. So 6 is smaller than 12. तो E को हम left side पे रखेंगे. So we'll keep this E on the left hand side. and C on the right hand side because greater है. पहले दो minimums delete करवाए, merge it. 6 plus 12 is 18. So these two are deleted. Now 18 will be somewhere here. टेक द नेक्स्ट टू मिनिमम्स. नेक्स्ट टू अब 18 के साथ मर्ज नहीं करवाएंगे. बहुत सारे स्टूडेंट्स क्या कहते हैं, जो भी आया नेक्स्ट एलिमेंट लिया. डोंट डू दैट. इफ यू विल बी डूइंग दैट यू वॉन्ट गेट द करेक्ट ट्री. और अगर ट्री के लेवल्स करेक्ट नहीं है तो डेफिनेटली करेक्ट नंबर ऑफ बिट्स आपके पास नहीं आएंगी. सो एवरी टाइम वी हैव टू गेट द टू मिनिमम्स. So next two minimums are 13 and 15. Since both are smaller than 18, so it will be a part of the left subtree. Part of the left subtree. Wait a minute. This was 9. I'm so sorry. Frequency of E is given as 9. Frequency of E is given as 9. This comes out to be 21. Wait, 21. 9, 12, 13, 15, 16 and 45. 9, 12, 13, 15, 16 and 45. Now this is fine. Now take the next two minimums. This is 13 and 15. This is the frequency for B and F. Merge 13 and 15. We are getting here 28. 28 will be going back to the min heap. तो यहाँ पे आपके पास 28 आ जाएगा. Now delete the next two minimums. It is 16 and 21. तो 16 को merge करवाएंगे 21 के साथ. 16. This is the frequency for D. Merge it up. 16 and 21. So this is returning. This comes out to be 7 and 3, 37. 37 वापस से स्टैक में आ गया. तो यहाँ पे 28 के बाद somewhere here we have 37. Take the next two minimums. 37 is greater, so it's on the right hand side. 8 and 7 is 5, 15 and 65. Then take A, 65. Take the next two minimums. A कहाँ पे आएगा? To the left side because 45 is smaller. This is for A. This is returning 110. टोटल फ्रीक्वेंसी फाइंड करनी है. ए के लिए कितनी बिट्स आ रही हैं? सबके लिए हम बिट्स लिख लेते हैं, फ्रीक्वेंसी लिख लेते हैं. ए बी सी डी ई एफ. Frequency of A is 45. Frequency of B is 13. Frequency of C is 12. Frequency of D is 16, 9 and 15. Now check at what level we are getting these letters. A is coming at the first level, so 1 bit is required. A के लिए एक ही bit चाहिए. B के लिए 3 bits are required. This is 2 bits. B, F and D 3 bits. B, F and D. C and E के लिए 4 bits are required. तो कहीं पे भी हमें कोड लिखने की जरूरत नहीं पड़ रही है. 4 bits are required. So this is 45, 39, 48, 48, 36 and 45. So you'll get here the total bits and finally return all the numbers. Is this clear? So quickly tell me that what average are you getting? Average find कर सकते हैं. So average code will be total bits divided by total frequency. टोटल फ्रीक्वेंसी हमारे पास यहाँ पे 110 आ रही है. गेट द टोटल. So 45, 45, 90, 90 and 96, 186 uh, plus 39 plus 36. So get the total. It comes out to be 12, 1. Let me write here. 1, 12 plus 9, 21. 6, 8, 16, 1, 261. So it comes out to be 261. So this is 261 divided by 110. That is the average code length. Okay, so this is the idea of the Huffman coding. अब यहाँ पे आपके पास 6 characters थे, कितनी बार repeat हुआ? Every time we are considering 2 minimums. 2 minimums लिए, first time step repeat हुआ, फिर second time step repeat हुआ, फिर third time, fourth and fifth time. So total 6 characters were given. So this step is repeated for n minus 1 times. If we talk about the frequency, if we talk about the time complexity for the Huffman coding, what we are doing is we are having the min heap tree. हमारे पास एक min heap tree है. We have the min heap tree. और min heap tree में हम क्या कर रहे हैं? We are deleting 2 minimums at every step. हर step के लिए हमें 2 minimums चाहिए. Delete one element, delete another element. उसके बाद आप sum लेकर जो भी result आता है, insert the result. Insert result. So this step is repeated for n minus 1 times. इस step को हम n minus 1 times repeat कर रहे हैं. And we also know that for one step, this is one step. हर स्टेप में हम 2 डिलीशन और एक इंसर्शन ऑपरेशन परफॉर्म कर रहे हैं. एक इंसर्ट या एक डिलीट के लिए दिस इज गोइंग टू टेक लॉग इन टाइम, बिकॉज हीप ट्री की जब हम बात करते हैं, बाइनरी ट्री इज सेड टू बी हीप ट्री इफ इट इज ऑलमोस्ट कंप्लीट बाइनरी ट्री, यानी कि ट्री बैलेंस्ड है तो नंबर ऑफ लेवल्स विल बी लॉग इन. तो वर्स्ट केस में जब आप एलिमेंट को डिलीट करते हो, ज्यादा से ज्यादा जितने भी ट्री के लेवल्स हैं, हर एक लेवल पे एक स्वैप होगा. सो दैट मीन्स टू डिलीट वन एलिमेंट, लॉग इन टाइम इज रिक्वायर्ड. ये मैंने डिटेल में डिस्कस किया हुआ है जब हम लोगों ने हीप ट्री डिस्कस किया था. इफ यू हैव एनी डाउट और एनी कंफ्यूजन विद द time complexity of deleting one element from the heap tree or inserting the element in the heap tree, then please refer to heap tree concept. मैंने time complexities बहुत अच्छे से discuss किए हैं उसमें. So एक step के अंदर 2 delete और एक insertion operation हो रहे हैं. That means it is taking 3 log n. For one step, this is taking 3 log n. और हम कितनी बार step को repeat कर रहे हैं? We are repeating this for n minus 1 times. n minus 1 times में हर बार ये 3 log n ले रहे हैं. So this comes out to be 3 is constant, or you can say that this is 3 is constant. So ultimately what we are getting something like 3 n minus 1 में से asymptotically हम time complexity return करते हैं. So n minus 1 is nothing but similar to n. So the time complexity for Huffman coding comes out to be n log n. You should know the time complexity. Obviously कोई भी आपसे derivation नहीं पूछेगा, but मैंने फिर भी आपके साथ discuss किया कि किस तरीके से हमें time complexity n log n मिली है. So we have analyzed each and every step, and on the basis of that we are returning the time complexity. So this is all about today's session, and in the next session I'll be discussing one more application from greedy technique, that is fractional knapsack. जैसा कि आपको पता है कि YouTube में हम सिर्फ और सिर्फ important concepts और important applications cover कर रहे हैं. इसका ये मतलब बिल्कुल नहीं है कि 100% syllabus या फिर हम ये बोले कि पेपर की प्रिपरेशन के लिए whatever is required 100% it will be covered in these sessions, because session की duration and the number of sessions इतने नहीं है कि हम लोग पूरा syllabus खत्म कर पाए, but 100% syllabus is covered in the super coaching. So super coaching batch जो है ये टेस्ट बुक प्लेटफॉर्म पे है. इसमें पेपर 1 पेपर 2 के जितने भी सब्जेक्ट्स हैं सारे के सारे कॉन्सेप्ट डिटेल में कवर हो रहे हैं इन द लाइव सेशंस. ताकि अगर आप लोगों के कुछ भी डाउट्स हैं, कंसर्न्स हैं, आप क्लास में पूछ सकते हो। ओके, apart from this, if you want to get to know more about super coaching, so please go to the description box. Description box में link दिया गया है, उस link को follow करके आप super coaching की details को access कर सकते हो, ताकि आपको ये समझ में आए कि what super coaching is and इसके benefits क्या है. Test series, notes, everything is included in the super coaching. Okay. Apart from this, YouTube पे मैं Wednesday, फ्राइडे और संडे को क्लास लेती हूँ. वी हैव द सेशन ऑन वेंसडे, फ्राइडे एंड संडे. बिकॉज ऑल्टरनेट डेज पे इसलिए रखे क्योंकि जो भी टॉपिक हम वेंसडे को कवर कर रहे हैं उसके बेसिस पे मैं क्वेश्चंस थर्सडे को करवा रही हूँ. फ्राइडे को जो भी हम टॉपिक कर रहे हैं उसके बेसिस पे वी आर कवरिंग द क्वेश्चंस ऑन सैटरडे. तो ऑल्टरनेट डेज पे हम कॉन्सेप्ट्स और क्वेश्चंस करें. दिस इज अबाउट द मास्टर क्लास. मास्टर क्लास भी फ्री क्लासेस हैं, इसके लिए आपको कोई सब्सक्रिप्शन नहीं चाहिए, बट डेफिनेटली दीज आर ऑन द टेस्ट बुक प्लेटफॉर्म. ये टेस्ट बुक प्लेटफॉर्म पे, बट इसके लिए आपको कुछ भी पे करने की जरूरत नहीं है. टाइम फॉर दीज क्लासेस इज सेम, so 6:30 p.m. Apart from that, we are having 2 sessions in the super coaching every day, ताकि हम पेपर से पहले सिलेबस खत्म करके टेस्ट सीरीज और प्रैक्टिस सेट, प्रैक्टिस क्वेश्चंस कर पाए. सो वन सेशन इज इन द मॉर्निंग एंड अदर वन इज इन द इवनिंग. दोनों सेशंस में डिफरेंट सब्जेक्ट चल रहे हैं, ताकि पैरेलली आपके 2 सब्जेक्ट्स चलते रहे और इन पे आपको इनफ टाइम मिल जाए रिवीजन के लिए. सो यू कैन रेफर टू द सुपर कोचिंग schedule. If you guys have any doubts or queries, you can ask. Otherwise, we'll end our discussion here. आपकी तरफ से आपका कोई डाउट? I cannot see any doubt. So this is all about this session. Thank you so much. I'll see you in tomorrow's masterclass. Till then, take care. Bye bye. God bless you.